Hello everybody, Brad the Guitarologist here with another mind-numbingly kick-ass video for you. I just want to take a moment though before we get started on this video to welcome a lot of the new subscribers in the last month. I don't know if you guys have noticed, but my subscriptions have really kind of shot up. So I want to welcome everybody who's new to the channel. I hope you guys take a look around. On my main page, all of my videos are separated into categories, so you can go there and you can see like different types of amps. All the Valcos are put together, and all the Gibsons are put together, and all the Fenders, etc. So it makes it a little easier if you're into one certain thing, so be sure to check that out. But in today's video, this will be in addition to that Fender playlist, and this is a 1960s Bandmaster head. We're going to go through this. I have a customer who dropped this off to me for repair. We're going to see what his complaint was. We will go through the schematic, take a look at the guts, see what's wrong with it, what it's doing or not doing, and if that sounds like something you'd be interested in, stick around. The features on a Bandmaster are pretty similar to some of their other amplifiers of the era, like the Blackface Deluxe, very similar as far as the controls and everything are concerned. We have a tremolo with speed and intensity on the second channel. They called it vibrato, which of course that's wrong, we all know. If I were to say something like that on this channel, you guys would know I would probably catch hell for it. I can't even pronounce tremolo without being berated for it. But you guys, I don't know, you can take the piss all you want, that's fine. This one has the kind of the long-tailed Fender logo, which is consistent with the era, but I think this grill cloth has been replaced. In fact, I'm pretty sure the owner told me that was replaced. We have also a normal channel with 3 controls, which is pretty typical of Fenders, with volume, treble, and bass, and a bright switch. There's also a bright switch over here on the vibrato channel. Let's turn this thing around and we'll get a look at the back. Alright, here's the back of the amplifier, and as you can see, it's pretty sparse and Spartan back here on the back of this amp. And I'm a walking thesaurus today, apparently. We have a vibrato pedal control right there. That'll turn your vibrato on and off, obviously, or tremolo. Or tremolo, for some of you picky fuckers. As you can see right there, Fender Musical Instruments, Santa Ana, California. Which is where they were headquartered at the time, or where these were made. Made in the USA. There's your UL logo. Can't make an amplifier without that. Speaker, external speaker, jacks. You always want to use the speaker jack first, because this will have a defeat on it. And if you try to use the external speaker, you won't have a load. Basically, you'll just have a grounded output. On switch with a standby, 2 amp slow blow fuse holder, and let's go ahead and check that fuse holder to make sure it's correct, or not the fuse holder but the fuse. Let's see, 2.5 amps, so that is not correct. We will set that aside and not put it in the amplifier, and we'll change that in a bit. Here's a ground switch. We do have a 3-prong grounded cord, so there's really no need for a ground switch with a 3-prong cord. But anything that's up to code, you should never have to have a ground switch on an amplifier. As long as the building you're in is up to code, just having the 3rd prong on there will suffice. Alright, here we are with the back door off, and we can see our power tubes over here, which are 606 GC's JJ brand. We have 4 preamp tubes. We would have had 4 power tubes on some other models that used this same chassis. That's why we have these extra holes here. They just stamp all these chassis, and then they would fill them with whatever tubes that the model demanded that they were building. So that's why you have those extra holes. You see right up there at the top it says AB763. Now this is a Bandmaster AB763, not to be confused with some other AB763s like the Blackface Deluxe. The schematic for that amplifier is also called an AB763, and it's really not a completely different circuit. It's very, very similar, but it does have some distinct differences, such as the output tubes, and the rectifier. This one has no rectifier tube. This is solid state rectification. We have a couple 7025s, a 12AX7, and then a 12AT7 in the phase inverter. Let's pop this chassis out of the cabinet and get a little closer look at it. Okay, here's a little tip for you. When you're unscrewing or unbolting these chassis from the cabinets, you have to reach up inside here and grab the nut so that it doesn't just keep spinning. You know, if I try to loosen this without reaching up in there, it'll loosen for a second and then it'll stop because this will just start spinning. The chassis is already dropped as far as it's going to, so there's no pressure to keep the thing spinning. So here's a little trick. If you don't want to bother to reach up in there, just get you a little screwdriver and stick it up under the strap. Actually, I don't know if this one will fit. Get something here like this will work. I'll show you with this one. But this allows you to, you can actually put some upward pressure, so you don't have to reach up in there that way. Makes it a hell of a lot easier, and then you can just let the nuts fall down inside and get those later. See? I'm full of helpful ideas, aren't I? Alright, we might as well take a look at the tube side of this chassis while we have it out. And we'll look at some codes here. The codes on the transformers are going to get us pretty close to the actual build date. You can see there's 606, which is Schumacher, 1966, 22nd week, and that's this code down here on the bottom. Manufacturer, year, 1966, 22nd week, and this will be a part number. We have very similar code here, 20th week, and this is an original part as well, as you can see from the 606. And this one, let's see, yep, 1966, 35th week. So this is firmly in 1966. I think there's no doubt about that. Let's take a look at the tubes. Alright, on the tubes, it looks like we have a JJ up front here. Let's see, that's an 803S. Which should work okay, but it's not really what the amp calls for. Well, man, getting that one back in is that's a chore. Oh, that's why. Look at that. That's the reason. See the bent pin? I don't know if you can. There you go. You can see that bent pin right there. That's the reason. This is gonna be a chance to show you another little tool I like. Let's see. And no, I'm not going to whip it out on you. This is a pin straightener. On one side it has 9 pins. On the other side it has for your 7 pins. We'll just insert it into the 9 pins. And it will straighten the pins. So it'll go back in. Let's see. Cool. So yeah, if you're looking for one of these, I'll put a description down, or I'll put a link where you can find one of these down in the description if you're interested. That's a cool little tool to have around, because it does happen a lot, and it makes it easier to bend the pins back into position. This is an ECC 83, so that's basically a 12AX7. The 803 is some special variation. I'll have to look at that. I can't remember exactly what that is. I was thinking 803. That was a DW7, but I guess I got to be wrong on that. There's another ECC 83, which, I mean, these will all work. There's nothing to say they won't work. And ECC 81, so that's correct. Let's open the doghouse and see what kind of adventures we have under there. Alright, we got a full complement of Sprague Adams underneath the doghouse here, which should be fine. The larger ones over here on the right are 80 microfarads instead of 70, which is what the schematic called for, but that's just fine. I don't see any problems with any of these resistors either. So we'll put the doghouse back on. That looks good. Alright, here are the guts of this amp, and everything in here looks fairly original, with a few exceptions, which aren't really a big deal. All of the bypass capacitors have been replaced. You see those two black Spragues right there. A couple more black Spragues on further down in the circuit, and another one there. You see that little red capacitor right there. That one's a replacement. couple of resistors down here, but look at how those are soldered on. They're kind of just laid across the They're kind of just laid across the eyelets, and they're not really soldered in down into the eyelets. I don't like to see that. I mean, I guess they're fine. I'll chopstick around on them and see if I can't get them. And they seem stable enough, but I just don't like that. If you're ever in a Fender amp, you know, clip off enough leads so that you can stick it down inside the eyelet holes. Don't just lay them across the eyelet holes like that. Just a pet peeve of mine. All the original molded capacitors are still in here. The one main problem that I see now, the complaint with this amp is that it was a little bit noisy. There was kind of an intermittent crackling or noise on some of the notes, and he wasn't sure what it might be, but he said it was kind of intermittent, so he didn't know. I'll plug into it and test it out here in a bit, but the main thing that I see that I definitely would change is the way that this power cord is wired. You know, for what he's talking about for noise, like noise and crackle and just intermittent stuff, that really sounds to me like a job of cleaning. So we'll come in here and we'll clean all of the input jacks. We'll clean the output jacks. We will clean all of the tube sockets, spray them out all really well, and see if we can't recreate the problem after doing all that. Okay, on these jacks, what I like to do usually is get a piece of maybe 1000 grit or 600 grit sandpaper, and what I do is just cut a length of this stuff. Sandpaper is always nice stuff to have around. It's always useful, but I cut a little sliver of the stuff and bend it in half, and it would probably be nice to have a little bit longer piece, but what you could do then is open up these jacks, and sometimes it's helpful to put a actual cable in the jack so it spreads them apart for you. So just stick a cable in, and it's going to spread these little contacts apart for you so you can get your sandpaper down in between and just run it through a few times, and that's going to just basically polish off those contacts. We're not taking any material away, really. We're not sanding down, because this is such fine grit. We're not sanding down anything. We're just basically taking the oxidation or the patina or whatever you want to call it off of those contacts so that they get good contact, and so this thing is grounded out when not in use. We also really need to do the same thing. We'll do something different to clean them, but we need to take these jacks, remove them from the front to clean those, because they get ground contact through the grounding bus up here. You'll see a piece of brass that runs the entire length of the front of the chassis. There's a piece of brass that's bent. It goes down here on the bottom, but it also goes up to the face, and that's where everything gets its grounding. And if it's not, if there's too much oxidation or patina on all these little contact points where it gets grounded, you can sometimes get intermittent noise issues from that as well. So we'll finish off cleaning these jacks, and then we will move along to taking components off and cleaning those. Okay, I've pulled these input jacks and just checking them out, and they are actually very clean. The previous tech who worked on this probably already cleaned these, and they look very, very nice actually, so I don't think I'm going to have to I might spot check a couple of these pots, and if they all look like this, I'm not going to bother because that's extremely clean. Alright, we've got this thing dialed up with nothing plugged into the inputs, and we're just listening on a little speaker right here. And I am getting some crackles and pops. Let's see. Just trying to wiggle tubes here and see if maybe, hear that? Sometimes that just comes from touching the chassis too, but there's a little something right there. Might be worthwhile cleaning that socket for sure. Also notice it's kind of cocked to the side, and I think that's because there's more tension on this little band than there is over here on this little band. So I might pull that out and just kind of adjust that and clean this socket while I'm at it. You hear a little popping, pop, pop, pop. Something going on there. I'm wondering if that's the vibrato doing that. Look inside that little roach right there. I don't see any light. I wouldn't expect to. But it does seem a little bit noisy, for sure. Notice there's one little spot on this pot where it kind of was dropping out earlier. It was real dirty. See it drop out. Right there it drops completely out. At one point on the pot, at a couple points actually on this pot. So I'll definitely clean these pots also. Yeah, let's go ahead and do that. Let's clean these pots, and I might as well jerk all the tubes out, clean all of those as well. And then we'll come back in here and we'll chopstick around and see if we can't figure out what's causing the rest of the noise. Alright, I've cleaned the sockets and everything, and I've got this thing back on, and I've been kind of playing it out here on the desk with this. I mean, granted, a little tiny speaker that probably isn't even enough power handling for this amp, but I don't intend on blasting it and burning up the voice coil, so it really doesn't matter. I just selected that because it was the first thing in hand that was 4 ohms. At any rate, I'm going to show you, since I'm not any longer getting the problem as far as the crackling and everything, the noise, I'm going to go ahead and check the bias, and I'll show you how to check the bias on this and other Fender amps of similar construction. If you look at the schematic on the Blackface Bandmaster, you'll see that it calls for, here's the bias circuit down here, here's the bias potentiometer, and that's that potentiometer right there, obviously, only one internal. It calls for negative 48 volts, and that's going to be at the wiper of that pot, so we can measure that. Okay, so I've hooked up my probes, one to the wiper, and my black one, which is my negative, to the ground, and we're getting about negative 49 volts, so that's close enough for government work. Negative 48 volts, it says, is ideal, and you know, that's probably 99 times out of 100 checking your bias in a Fender this way is going to be fine. As long as you get close to what it calls for on the schematic, on any of the old Fenders that have this fixed bias like this. And when I say fixed bias, I don't mean it's non-adjustable, because obviously it's adjustable. But what I mean is there is no cathode resistor that is biasing from the cathode. The cathodes of these tubes are just tied directly to ground, and the bias is adjusted here. So that's what's called a fixed bias. At any rate, as long as you get close to what it calls for on these old Fenders like this, usually you're going to be just fine. You're going to be well within the parameters of whatever output tube you're using, in this case 6L6. But what we're going to go ahead and do is just double check and make sure the plate dissipation on these 6L6s is about ideal. Alright, the first thing we're going to need in order to check plate dissipation on the tubes is to check plate voltage, and that's pin 3 on both of the output tubes. So try pin 3 here and we'll get that measurement. That's 457 odd volts, so we'll write that down. Okay, and pin 3 of the other tube is also measuring 457 volts to ground, so we'll write that down as well. And just a note on this, when you measure the plate voltages of the output tubes, they should be very, very close. If they're way off, that can sometimes mean that your tubes are extremely mismatched, and sometimes actually that can be a good thing as far as tone, because that can accentuate some different harmonics in your tone. But at the same time, for the amp to run ideally and most efficiently, they need to be pretty closely matched. And if this plate voltage is way off on one or the other, then you need to be suspicious that your output tubes are violently mismatched. And we will also note while we're at it that the 457 volts that we measured is also very close to the 440 volts that they call for. And this is, back in 1966, so the voltage has steadily crept up in most households. The input voltage from the wall, actually, you'll get more volts out than they got in the 1960s in most cases. So that could account for the difference here. So there's nothing to be alarmed about, and that's small of a difference. But we are also now going to measure from the center tap of the output transformer, which actually, if we follow it down, ties to the standby switch. So you can just take your measurement right off the standby switch to each of the plates. Right now we still have our lead on one of the plates, so we can simply move our black wire from ground, and we'll move it to the standby switch. Okay, so with one of our probes on the standby switch and the other probe on the plate, we have a voltage difference, an absolute value of 2.2 volts, so we will write that down. And we'll move our positive red probe back to the other plate again and take a measurement from there, and that one's 2.06 volts, so we'll write that down. Okay, so we've written those figures down, and now we need to measure the resistance from each half of the output transformer to the center tap. So first things first, let's shut the amp down. Shut off our input power supply as well. Wait for the thing to cool down. We'll set our meter to ohms. And right now you'll notice getting a very high reading, like very high in the megs, which is probably too high. So that's telling me I'm actually on the wrong side of this switch. So I could close the switch. If I just take the switch in the up position, I'll show you the difference. Here's in the down position on the switch, because I was on the wrong side of it. I could just move the lead, or I could just flip the switch, either one, with the amp off. So we have about 70 ohms on this side from this plate to the switch. Now let's check the other plate to the switch. So we'll move this probe over to this plate and check this value. And we have 70, so 79. So 70 ohms and 79 ohms. Let's write those values down. Okay, so let's calculate some plate dissipation. First thing we need to do is 2.22 divided by 79 ohms. So 2.22 divided by 79, and we're going to multiply that. That's actually our plate current right there. We're going to multiply that by 457 volts, and that will give us our plate dissipation for that one tube. So 12.84. That does seem way off. Okay, we're back to measuring the voltage drop across one half of the output transformer, and we're back to our original reading that we were getting before, and we want this reading to go a little higher. So let's turn the pot until our reading gets a little bit higher, and then we'll remeasure. Let's maybe send it up to about, let's try about 2.7 or so. And then we'll do some measurements on that, see where that gets us. When you make a change like that, you also have to remeasure the plate voltage. So we'll leave the red probe right there, and we'll carefully grab this one off and put it back to ground. And now our voltage on the plates on that plate is at 450. So let's do the math. Okay, as we can see here with our 450 plate volts, our 2.7 voltage drop, that's gotten us to 15.3 watts of plate dissipation. We went from 12.8 up to 15.3. So let's go a little further with it and see if we can get a little closer to 20. Alright, doing the math again with the 3.7 volts voltage drop, we've gotten an outcome of 20.8 watts. Alright, doing the math on the other tube, I'm at 21.6 watts on that one, so we're real close and right within our 70% target spec. Now we measure again on the wiper of our bias pot, and we're seeing about 43.3 volts. So on this particular example, about 43.3 volts with this particular set of tubes is the ideal level as far as I'm concerned. So this is going to be a lot better. Alright, it's a new day. We're back here with this Bandmaster, and I've spoken to my customer, and he says he does indeed want me to go ahead and wire this power cord correctly, which I assumed he would want me to. But we're going to do this correctly, and I'll show you how it's done. Okay, I've wired this power cord, and I will put a link down in the description below on this video to another video where it kind of shows you in general how to do new power cords with Fender amplifiers. But for our purposes here, we'll just go through it quickly. We have the black wire coming to here. We've bypassed the ground switch and come over to the tip of the fuse holder. It goes through the fuse and to the sleeve of the fuse holder, goes out of there and goes to the switch. On the other side of the switch, it goes to the primary winding of the transformer, out of the primary winding, and then back out through this point. So that's pretty much it. We don't need the ground switch anymore. And by bypassing the ground switch, we also bypass the death cap, which is right down here. We don't have to clip it out or anything. We can leave it exactly like it is. So if some persnickety person in the future wants this to be back exactly like it was stock, they can always come back in here and put their death cap back in and their two-prong cord if they feel froggy. So there's that all done. And now I think it's time that we can put this thing back in the cabinet and give it a test. Okay, that was the normal channel. Now let's check out the vibrato channel. And for this, we're going to actually use a little jumper. You have to have a foot switch in order for the vibrato, or well, tremolo actually, to work on Fender amplifiers. And I think most all cases are that way. So. So that concludes our service on this 1966 Fender Bandmaster Blackface head. Hope you guys have enjoyed the video. If you have, please hit the subscribe button. And for now, y'all take care.